Good afternoon. How's everybody doing?
Good.
Good, yeah.
Great, especially since you say that so optimistically. uh, so, um, where'd we leave off?
We left off talking about circuit bursts, and we're talking about our inputs and rows and black boxes and rows and the equals and not gates and the not gates and the Tom and the Jerry. And stop it! What are you doing? Not you. Yeah, we had all this stuff, all the stuff we did yesterday.
Okay.
I promise there's a method to the madness.
I understand completely. Um, I did not do my homework, I confess. So I still need to make sure that I've got access to various projects and do the whole thing there. But so I'll assume that works. And I don't know what that was. Okay. We did say that, excuse me, you would create a project with your name and then make me a collaborator. Everybody good with that? Any questions on that? The next thing, I suppose, is the assignments, quizzes, reports, whatever you want to refer to those things. So the way that you earn the grade in this course is by submitting one of those each week. They are in Brightspace as quizzes. They become available on the Thursday of each week. And all this is supposed to happen. Let me know if it doesn't for some reason. But they're supposed to become available on Thursday morning of each week and then be done at the end of Sunday evening, which means today's Thursday. So our first one should be available. And it's a report. I'm asking you to just summarize. Doesn't have to be extremely formal, but summarize what you did during the week. Okay, so all that stuff that Isabel just said, dump that out there, kind of thing. But basically, should say something about truth tables and circuit verse and that kind of thing on there. And then I will also have your circuit verse circuit to look at, so I can establish assign a grade based on that. And basically, if you keep up with what we're doing, there's no trouble. It's that easy. Any questions on that?
Yeah, we can start the quiz. I just looked.
Okay, good.
We can start the quiz. Yeah.
So the question was, well, okay, when should I do that? And well, you not saved your creation.
It's because it's untitled.
I was waiting. Oh, it's going to do this crazy.
It's that thing from before.
Yeah. Yeah. Okay. When should I do it? And my response was something like, I know myself well enough to know that if I left it till Saturday or Sunday, I probably would forget about it. So I would recommend like Friday after class. Do it. Kind of like that. But you can do it now if your Friday is going to be busy or something like that. Do it on Thursday, kind of like that. The intent was because they become available during the end of the week, so you can report on that week. If you report on Thursday, obviously you can't say what happened on Friday, but that's okay. You'll get it in the next week. So I'll get with that. Don't stress about it too much. Like one big project, keep up with it, get it all done. Okay, what is this crazy thing doing? So I'll do it this way, come back here. Hopefully the last one is my most recent one, F26, and I'll launch that. Okay. And all these toolbars, I usually just shove them out of the way. We may or may not use some of them. There's our good old not gate. And we talked about the idea that it's a little weird, but this is an input element from the user's perspective, but the terminal on this becomes an output to the circuit. And that output connects to the input of this gate. And we'll always connect outputs to inputs. And you can connect one output to as many inputs as you want, but you cannot connect more than one input to an output. It causes a conflict. Okay. And then the same thing. This, from the circuit point of view, is an output to the user to indicate state or something like that. But the terminal on here is actually an input that is connected to this gate's output. Okay. Yep. That's what I thought. Silence, the sound of complete agreement. Then we also looked at draw IO. Okay. And we started looking at truth tables. And we said that, okay, for a device with one binary input and one binary output, there could be 4 different behaviors, 4 different black boxes for it. And we enumerated them all here. Only one of those, or I should say one of them, is most useful, more useful than the others, and that is the one where the output is not what the input is at all times. And so we call it a NOT. Sometimes I'll call it an inverter because the output is inverted from the input. So that will be one of our 3 basic gates. We also were analyzing our system based on Tom and Jerry. Point there being, there is nothing magic about ones and zeros. I will probably start pretty soon using ones and zeros even in my truth tables, but only because I have great confidence now that we're really starting to appreciate the fact that the computer has no idea what a 1 is or a 0 is. Yep, complete agreement. Okay. So then we said, well, okay, what happens if we think about a device with 2 inputs, 1 output? That would double the number of rows, double the number of possible combinations of inputs. And we even thought about, well, what would happen if I added a third, a fourth, and a fifth? And, oh, okay, that's going to double the combinations every time since we're in base 2, binary, kind of like that. So we have this handy way of saying, okay, for some number of inputs, 2 to that power will be the number of rows I should have. All the combinations. And then we said, okay, how many different unique behaving black boxes will there be with 2 inputs and 1 output?
It'll be however many, like 2 to the amount of rows that you've got.
Yes. So, yes.
Sorry.
Stop that.
What did we mean by black box again? I remember the conversation about it, but in this context, like.
So a black box is something that you can interact with, but you don't know what's inside of it. You can't see what's inside of it to figure out how it works or anything. So all you can do is interact with it and see how it responds. And if you interacted with it in all the ways possible, and remembered all the ways that it responded based upon how you interacted with it, and it responded always the same way for each interaction you had with it, I would call that a black box. The computer science term we like to use is abstraction, and abstract. What does the word abstract mean? Can you use the word abstract in a sentence that has nothing to do with technology?
I guess kind of out of there. Like it's not really like a direct form necessarily. It's kind of.
Yeah, like abstract art, comes to mind usually. And you're like, oh, yeah, the artist was trying to convey something, but he left out a lot of the detail, and I'm supposed to fill that in, kind of. And so in computer science, we do this all the time. We say, okay, there's some complex system. We're going to abstract away the details and model it, and then, worry later about the details when we need to. So the black box is that kind of thing where we're saying, okay, don't worry about what's inside of it. Just let's see how it behaves. How and it's got inputs and outputs, and how the outputs behave based upon when we change the inputs. Yeah. These gates that we're talking about, for example, could have a mechanical implementation So the stuff inside the box could be mechanical gears, levers, wheels, pulleys, things, or it could be electrical, which is most common these days. Um, um, but it could be something else too. As long as it produces a behavior. Uh, so sorry, I'm thinking about the electrical and the hardware part of it that I mentioned in the first day something, and some people seem kind of interested in it. Is that still true? I don't know. Let me know. But yeah, that we could look at making these black boxes. Anyhow, that's for another time. We said the number of possible black boxes with different behaviors would be 2, because it's binary again, to the power of the number of rows that we have, which is 2 to the power of inputs that we have. So you can do the math on that. And if you do, what you come up with is that for 2 inputs, there are 16 possible black boxes. So 2 to the 2, there's two inputs. That means there's 4 rows, 2 squared rows. And then 2 to the 4th is 16. That's how many black boxes there are. And your assignment, that I'm not going to grade, I'm collecting it. But the recommendation was, can you enumerate all 16 of those? Now the moment of truth. Has anybody done that yet? No. Well, fortunately, I said yet. So, you've still got time on that. Is there anything, and I guess here's the real question. What is stopping you from doing that? What is stopping you from enumerating all the 16? Just looking to see if there's anybody out there. Oh, Deb's out there. She hasn't said anything. Ian.
I'm here.
Is here. You're Ian, right? And you are Noah. Oh, okay. Yes, Isabel and Cam. I know you got. So yeah, the question is, what is stopping you from enumerating all 16 of these?
I just haven't done it yet, and also it looks like it's going to be right. Sorry, I haven't done it yet, and I also it looks like it's going to be tedious, and I'm not procrastinating. I just haven't.
I'm just picking on you.
I haven't done it yet.
We all do it all the time, kind of thing. Like I said, it's amazing. When you become conscious of it, and you're like, no, I didn't do it. Yes, I did. Yeah, no.
Enumerate, you just mean terminal numbers?
List them out. Okay, so here's the first one. Here's the second one. Here's the third one. Here's the fourth one.
To do any of the text boxes on this computer is a little annoying.
So I'm. I don't know. I did what we well, because when we finished, we talked about how in the same black box we can just continue on one giant 16 columns long black box. That's what I did.
Okay. Yes, I was suggesting that you could put all of the 16 output columns on one truth table. Or you can draw 16 separate truth tables. That's up to you.
Did you want 16 separate truth tables, or was this okay and I was just supposed to label above them?
Either way is fine with me. It's the whole intention there is that you get the pattern down. Okay, like I said, I'm not collecting it, I'm not grading it, but I strongly suggest that you do it.
Okay.
And if you have,
it is in my notes.
What's that?
It is part of my notes now.
Okay.
I'm not sure how it's really hard to not say words I'm used to. I don't realize how much I say that. Wow, that's terrifying. My brain isn't wrapping around because we called above not and not, and then all Tom or all Jerry. So I'm trying to
Okay. So let me
make
say
name with my brain.
okay. So let me say this first. The answer to the question, what is stopping you from doing this? And you're struggling to come up with a reason. You know it's there, you just can't put it into words, which is cool and great. What I was kind of expecting was one possibility would be I just don't have the time. And I'm like, okay, I can't help you with that. Wish I could, but I don't have a time machine. So if you just haven't had the time to do it yet, not much I can do with that. Find the time. Okay. The only thing I can do is say, don't stress about it. There's not a due date kind of thing like that. So find the time, and when you do, you can. I suppose another answer would be, I don't care. I'm like, well, I can't do anything about that either. I'm doing my best to motivate you, but in the end, it's up to you. Like I said, it's not graded, so if you don't do it, it's not going to hurt your grade. But clearly, there's some understanding that you won't get until you actually do it on that. And all the other answers, which I think seems to be like where most of you were, where like you were hung up on the labels or something like that. Now that's something I can do something about. So if you can put it into words, I can try to help. With the one input, one output black boxes, we came up with the truth tables, and then we said we would label them according to their behavior. So yes, you should be able to do that for all 16 of these 2 input, 1 output black boxes, but admittedly, some of them are gonna be, I don't know. Let's do it. Yeah, no.
I think I understand the one input, one output ones. I don't know what it is. I'm just having a really hard time understanding everything else so far.
Okay, and that's fine, and especially that part like I don't know what it is. You know, there's something there. Okay, so
I can. Sorry, I didn't mean to interrupt you. Like I can understand the first part we did. There's just something that's not clicking in the second.
Let me try this, because with the first part, with the 1 input, 1 output, I actually started by being over here in CircuitVerse and pulling this up, which turned out to be a NOT gate, but it had 1 input and 1 output. So let me come over here and, oops, not that, grab a gate that has 2 inputs and 1 output, like this thing here, okay? And you can see there's a few of them here. And so then I'll say, okay, well, it's got 2 inputs, so let me grab 2 inputs here. And it has 1 output. I'll make a copy of that. Oh, that happens all the time. One thing you can do is you can just drag the terminals on top of each other and they connect. So that's kind of handy. The other thing too is when you're doing a whole bunch of these, and we will do a bunch of them later, if you select multiple inputs and drag them on top of multiple terminals, they all connect. So little shortcuts. The important thing here is how does this black box behave? Well, we've got 2 inputs and we have 4 possible combinations. No, not yet? Okay. What's that? Anytime, whenever you're ready. You know the answer already. Okay. And that's going to be actually a problem for you, is you got to put yourself in the shoes before you knew that. And say, okay, I've got 2 inputs, 4 possible combinations. Which combination do you want to start with? And this is where it'll help a little bit when we were talking the other day about doing this. And we said, well, there's a couple of ways we could think about it. We could think about the fact that we start with 2, and then we double it, and then we double that kind of thing every time we add another input. Or we could think about the number of preferreds. Okay, like I think we were using like T. So we said, okay, there's one combination where there are no T's. there are however many inputs I have, in this case 2, so I'll go with 2. There's one combination where there are no T's. That would be the second row that we have here. There are 2 combinations with 1 T. This is one, this row is the other. And then there is one combination where there are 2 T's. That's this one. So, so we could do that. Over here, we could say, okay, what if there were no ones?
Then the output would be 0.
Then the output is 0. Yes. Okay. Now, what if one of the inputs was 1, and I'll say this one?
The output would still be 0.
The output is still 0. Okay. What if one of the outputs is 1 and it's this one? The output is 0. What if there's 2 ones?
Then the output is
And the
1.
output is 1. Okay.
Is that because is 0 the favorite output? Why is it 0 over the 1? Or is that getting too far ahead?
No, I think it's a great question. Trying to think of the best way to answer that. Cam, did you want to take that one?
I don't have an answer. I have another question.
Oh, go ahead, ask your question. I'll try to answer. I'll try to remember answering both. They may be related. They may.
How are you doing these tables without labeling which gate you're using to make the table with? Unless you know that in your head, you just didn't write it down and tell anybody.
I've not labeled them because that's actually, I think, Deb's question. That's like 3 questions ago, kind of like that, with the labels. And I will create the labels after I have the truth table, because the labels, I want the labels to describe how it behaves, so I have to know what the behavior is first.
So you make them.
Let's do this, because the other thing I should do here is in CircuitVerse is no different. I have an input here. If I select this input over here under properties, you can have labels on them, and we should do that. Okay, so I'm going to label this one A, and I'm going to label this one B. Probably ought to do D0, D1, like I've been, okay, yes, for consistency. I will label this one D0, and I will label this one D1. Okay. We can label gates as well, and we should get in the habit of doing that. If we're going to label a gate, I would label that with U, and then a number. That's a common thing engineers do on schematics. U is in unit, kind of thing. So that's U1. And notice I put the label over there. You can move it around, label direction. I'll go to up. Okay, there's over there. And then my output, I should label this as well, and I'm just going to label this one Q. That kind of follows the convention we've been using the truth table. Okay, so now, can you picture the truth table for this?
Yeah, it would be like 0, 0, 1, 1, 0, 1, 1, 0.
Okay, so we said if both the, you know what? I'm going to switch to zeros and ones now. Okay, as much fun as Tom and Jerry are, if it's 0 and 0 in, we get a 0 out.
Yeah.
When we put a 0 and a 1 in,
So 0.
we got a 0 out. When we put a 1 and a 0 in, we got a 0 out. And when we put a 1 with a 1 in, we got a 1 out. So there's a truth table for that device. The question is now, what do you want to label it? How can we describe for all 4 cases what the behavior is, what the output value is with respect to, woohoo!
I'm so proud of you.
I don't know if we're proud of, but proud of.
Cam.
1 and 1 makes 1.
I like the way you said that. It's going to bother some people mathematically, you know. But when
How you would.
oh, go ahead. Here's the way I would think about it. Okay, and this comes back to that notion which I've said a few times and we haven't really done. We really need to pick one of our values as preferred.
0 preferred in this one?
Well, would you prefer 0 or 1?
I would prefer
One.
1, because one is
One is
something and
something.
0
1 is better than
nothing.
nothing, right? Yeah. So that's what most people do. Okay. Most of the time. We'll flip it sometimes, but okay.
Oh.
Most of the time people prefer, what's that?
Okay.
Most of the time, most people would probably just instinctively agree that 1 is better than 0. Okay, 1 is my preferred value. The reason why that's important to me is because now I can say, what are the conditions for the inputs when I get a preferred value out? And ignore the others. Because if I don't get a preferred, there's only one other possibility. So I look at this and I say, okay, when do I get a preferred out of this black box? Well, in this case, and only that case. So what is true about the inputs in that case? And only that case. They're both 1. D0 is 1 and D1 is 1. D0 is preferred and D1 is preferred. So I'm going to call this thing an AND. Finally, Cam says. Come again. The only time I get a preferred out is when one input is preferred and the other input is preferred. That statement is not true for any of these other 3 rows, right?
I really don't like that I already know this because I'm trying to learn it your way and it's making it so much harder to follow.
I get that. And believe me, I get it. The same thing will be true in problem solving. But I meant to say, and I hate to keep blurring classes, but even with this stuff, it's the same way. So whether it's the Python stuff or whether it's this logic stuff, I would encourage you. There are tons of videos and tutorials and things out on the internet where people try to teach this stuff. I would encourage you, go look at that. AI, ask AI about it. See what it says. I encourage you to go look at it. The more ways you see it, the better. I'm giving you my way of looking at it, which is not the simplest. I'm trying to draw a lot of generalities here. It would be easier, I admit, if I gave you very specific cases. But then it's like, what happens when I come across something that's not one of those cases I know? It's not a recipe I know. How do I make it? And by looking at these generalities and looking in terms of preferreds and not preferreds, by looking at the number of rows based upon the number of inputs, kind of stuff like that, that generalizes to any number of inputs and outputs.
I think I understand it more now. That makes a lot more sense. I guess I won't apologize, but the only thing is there any specific reason that, at least for this AND gate, zeros, like a 0 and a 1 is still a 0 instead of a 1 and a 0 being well, that would be
That's
I know nothing.
No. You're right. No, and
things
so
that may be obvious to you are not obvious.
right, and yeah. So we all need to be aware of that. We all come at this from different experience levels and so forth. And that's not a problem at all. So I think the answer to your question is no.
Okay, if it'll be answered later too.
No, I mean, can you ask the question again?
I guess I was just. Is there a reason why zeros like why?
No.
Okay. So there's no reason for it. It's just how it is.
That's just how this black box behaves.
That's perfectly fine. That makes sense.
And I think that's why you said it was called a black box, because you're not supposed to know how it works, you just know it does.
And fair enough.
Yeah. So if you come across one, I've often in the past I've done this thing where I say, you are about close your eyes and become transported to this binary world. So everything here is binary. There's nothing but Toms and Jerry's or ones and zeros. Okay. I'll go ones and zeros. There's nothing but ones and zeros when you look around, except for some black boxes. And so you're exploring, wandering around, in this world and you come across one of these black boxes and you notice that it has 3 spots in it. What do? So you've got ones and zeros laying all around, thinking like maybe like coin-shaped things or something like that. Okay, they're all over the place, and that's all else there is besides these black boxes. You can pick up a 1 or a 0, and you can hold it in your hand and move it around, turn it around, kind of like that. Okay, and then you pick up this black box, and you notice it's got 3 holes in it. What do?
Put one in the black box.
You pick up a 1 or a 0 and you stick it in the box, or at least you attempt to stick it in the box, right? You can open your eyes if you want, but or you keep them closed. And what you realize is when you picked it up, I suppose I should say, that out of one of the holes is coming a stream of 1s or 0s. Okay. Doesn't really matter what they are. Different black boxes might be different. But then you put a 1 or a 0 in one of the other slots. That may or may not affect what's coming out. You realize when you put a 1 or 0 in the other slot, that may or may not affect what's coming out. And it seems kind of random. But when you pick up 2 zeros and you put them in both of the slots, you start getting the same thing out. But if you put a 0 in one slot and a 1 in then you get something else coming out of the box, but it's consistent now. And so you notice that for this particular black box you picked up, the only time the stream of things coming out of it turn into 1s is when you put 2 zeros in.
You mean 2 1s then?
Yes.
Okay.
I was confused for a second. I apologize.
I was gonna ask you.
You're talking about an and gate.
I would love to say that was a test and that was a learning experience. But no, I didn't.
I understand that a lot, but that's just how it is. So that makes
That's
like
think
you
of
said,
it. You were just transported, dropped into this world.
Yeah.
You're exploring it. You're trying to figure out how things work here, what's going on, kind of thing like that. And you're trying things and observing what happens and then trying to explain it.
Okay.
And so you label that black box an and, because the only time that you get 1s coming out of it is when you have a 1 and a 1 coming in. Now, close your eyes again. You're back in this world. You're wandering around and you stumble across another black box. Okay. And it might look the same, but does it behave the same? And I'm going to suggest, you can open your eyes now if you want to see this, that when there are 0s coming into the black box, 0s come out. When there's a 0 and a 1 coming in, ones start coming out. When there's a 1 and a 0 coming in, 1s are coming out. And when there's 2 1s coming in, there's 1s coming out.
So
That's Dunban over there.
I think I understand a lot more now. So, and is representative of if there's a 1 and a 1, then you get a 1 from the output. And
Yes.
Or is if there is a 1 or a 0, you get 1 from the output. That's preferred. Is that how it works?
Close.
Okay.
Really close. Except that what about the last case here?
A 1 or a 1 still equals a 1. Is it also 0?
I'm going to come to that in just a second, but I want to make sure. Deb, did you say something? Did you want to say something? I heard something, but it was quiet. No, okay. That might have been something. Suppose that in this case it was a 0. So these are 2 different kinds of black boxes. They behave differently. How do you want to describe the behavior when you get a preferred out? Go ahead, Isabel.
I would call the one with the 2 zeros being 0 0 and 1 1 being I would call it an inverse gate, because if it's 2 of the same number, it gets out a 0, but if it's 2 different numbers, you get a 1. So in that semblance, I would think like an inverse or a reverse gate. I don't think that's the real title, but that's what comes to my brain is like it's an inverse. It's wrong, but it's right. It's a negative positive. It's a faux pas.
Okay. Okay. I definitely think most people would agree with that idea that whether the two inputs are the same or not,
Mhm.
kind of thing. We use it, and we use this for that for that very purpose a lot. How about this? Somebody use the word or, in a sentence, again, that has nothing to do with technology.
Do you want cookies or cake?
There you go.
Do you want what or cake?
Do you want cookies or
Oh,
cake?
okay. Do you want cookies or cake? Can I have both?
Yes. Well, you could, but the point is, or is a choice means you have one or the other, and it's
It
a
depends
choice.
on who
But
you're asking.
but that you can have both. I would
If
let you have both.
If I said to my mom both, she would make me both.
I mean, I want cookies and cake, but the question wasn't that. It was, do you want cookies or cake?
Mm-hmm.
I still want both, though.
I
Just
do
for the
too.
record.
And I guess the question is that permitted? Is it permissible? Is it allowed? Does it make sense? Can you say, do I want cookies or cake? And I say yes,
Yes, because that's.
meaning I want both.
I mean, that is an answer. If you want to be
You were
usually what I
with me
say.
right up to that point, I thought.
I think
The thing is, we use it both ways.
well, this could be wrong, but would one be representative that you have something? I guess so. Like, if you have one or the other, you still have something, and then if you take both of them, you still have something. But if you don't take either of them, which would be the zero, you have nothing.
So again, when it comes to why these things are useful, this one, yes, will tell us that we have at least one.
So you can have both because that's representative.
You have at least one, but you might have two.
Okay.
This one tells us you have one and only one. You have one, you don't have two. You don't have both. So what we'd say then is that this is an inclusive or. We're including the case of both, and this is an exclusive or. Which, if I spell it right, first of all, with the X in there, then a lot of times you'll find we abbreviate it to XOR. And
you're bringing everything back every time you say a new word.
If you've played with this kind of stuff before, which you have, yeah, then yes, you've seen it in one shape, form, or another. And the inclusive or is sort of the default. That's usually what we mean. So if we just say or without specifying, it's inclusive. And if we mean an exclusive or, then we say exclusive. So with the inclusive or, yes, I can have cookies and cake. But if you tell me it's an exclusive or, then I can have one or the other, but I can't have both. And now I've got to really struggle and say, geez, which would I prefer? Do I want the cookies or do I want the cake? Why are you doing this to me?
Control D, not D.
That's the same thing as copy as control P is not paste, it's print. You control V for paste.
There's a lot of conventions with shortcut keys, but they're not standardized. So yeah, different apps do them differently. And some apps allow you to program them. I'm just giving you time to finish your notes, right? No. How many times do I have to tell you?
I'm probably going to need a neon sign for that.
We're all in it together, yeah.
This is the neon sign of no just and no sorry.
No just, no sorry. I'm taking everything away from you.
You are. It's so mean.
But we're getting coffee or cookie and cake, right?
That's right. That's right.
That's fair.
And that sounds like a fair trade to me. Yes, I would gladly trade my justs and my sorries for cookies and cake. Of course, somebody's gonna say, "Well, I want both. I want all of it." Okay. So it turns out that the and the inclusive or are the other two of the three that I've been saying all along. Oh, there's only three gates we need. The not that we have, and now the and the or. Everything else, including the exclusive or, can be made from those three. Which is one of the things we will do soon.
One we need?
The and, the not.
Ah,
So the not is the first one,
not
and then the and the or.
Okay.
Those are the three gates we need. We'll build everything else from that. But I do feel like, since I'm harassing you, that I will do a little more and say, let's consider one other black box. Again, you can do the other 13 or whatever when you have a chance. We need to change one of these values at least. Which one do you want to change? Row 1, 2, 3, or 4? I just missed an opportunity. I should have said, which one do you want to change? Row 0, 1, 2, or 3? Because we're going to get used to start counting with 0.
0.
Row 0. Okay, so I'm going to change that to a 1.
This is Europeans labeling building floors. You want the ground or the first floor?
no, because then their first floor is the second floor because they are weird.
Yes, that's what they do.
So I changed 1. Do you want to change the second one or not?
Sure.
Okay. 0, 1, 2, or 3. Which one do you want to change?
Let's change 3.
Okay, so 0, 1, 2, 3. That's this row. I'm going to change that. I'll go with it. Do you want to change another one?
Sure.
Okay. Which one do you want to change?
2.
2. 0, 1, 2. This one. Okay. And I'm not going to let you change anymore.
I didn't see what you changed at first. I was copying it. So.
I
One.
forget. I think we changed row 0 first, and then we changed row 3, and then row 2.
My bad. I was trying to copy things and I didn't see what you did.
Yep, I get it. Now the question is, what do you want to label this black box? How does it behave with respect to the inputs? Again, on when, how
So it's
can I
only not,
go ahead?
it's not favorable only when it's 1 and 0 in that order.
Did you catch what she did to me? I almost fell for it.
We're favoring 1, right?
Yes.
What did I do?
Oh, he
Can-
got that face after you said the not. Is it like
Yeah.
a
Remember a few months ago I said there'll be times when we'll invert the logic. Like we're saying 1 is preferred. But when you said, oh, there's only one case where it's not preferred, now you're assuming 0 is preferred,
So 1 and 0.
which is legit. But just be careful of the switch. We've made that switch. So 0 is preferred when and only when D1 is preferred and not D0. D0 is not preferred.
Okay.
I was gonna say exclusive or, but that's not how that is either.
No, it's not an exclusive or. It's not an and, it's not an or, it's not exclusive. It's some other crazy thing. I don't know.
Is it a not?
It's not one that we use very often.
You can see why.
But it demonstrates the fact that, hey, it's a legitimate possibility that could exist. The question is it usable? How usable is it? So what I would say is, again, sticking strictly to 1 being preferred, then we have to say, okay, what is common in these cases that is not common in the others?
that it's 1, 0 in that order?
The order, as it turns out, doesn't really matter. If you're talking about like the order of the rows.
Like a 1 in the D1 input and a 0 in the D0.
Do they have anything in common?
What's that?
Do they have anything in common that the other one doesn't have?
I think so.
The order, like that 1 input is a 1, input is a 0 in that order specifically.
Yes. Okay, I get what you're saying now. Yes, exactly.
What?
Can
So
you
could I make this like 1 plus 0 equals 0? Because that's the only that is like the defining one that, or does that change the preference? I don't know, because it seems like it's going to be 1. It's going to be preferable unless you do 1 plus 0.
In this situation, it does equal 0.
So, Noah, can you say that again? And maybe can you word it differently?
That I guess one specific input has to be a 1 and the other specific input has to be a 0. It matters which input is like the order in which the inputs are
Bottom
followed.
one is 1, 1.
So I think what he's saying is that to get a 1 out in one of these 3 cases, that means that D1 is a 0. Or if D1 is a 1, then D0 has to be a 1 as well. If D0 is a 1, that's enough. It doesn't matter what D0 is. So we're saying, okay, D0, or excuse me, D1 is a 0. I should write this down. D1 is 0. Or if it's not, then
Both are 1.
D1 and D0 are 1.
So a gate can be both a not and an not an. It can be both an or and an and. If I'm understanding that right.
I want to say yes to that. Because do you notice what we just did? To evaluate this logic, we're using an or and an and. Remember I was saying that we can build any of the other truth tables with nothing more than nots, ands, and ors. Another way to say that.
Make it a Zand?
I don't know what you're going to call it if you want to like pick one word for it. But I'm saying this is really the logic. This is the logic for it. If you want to come up with a word for it, be my guest. I don't know what it'd be though. No.
Are there circumstances where this would be useful? With this type of black box or gate?
Yes.
So if it was an exclusive and, I was going off like so, like X and then and, so Zand. X and, I'm not sure if that works out.
I mean, if that makes sense to you,
Exclusive and. I don't think that's how that works.
what's that? The one thing I would say, so like I said, the logic to make this work, or to be able to determine what the output is that D1 is 0. That covers these 2 cases. Or D1 and D0 are 1s. That's this case. That excludes this case, which is not true. Now, the one thing I would do is, because again, we're thinking of 1 being preferred, and we have a 0 here. So what if I said not D1 or D1 and D0. And I think what I'll do is, let me do another sort of intermediate step here. Because I think what if I said, not D1 is 1, or D1 and D0 are 1. And also, to help clarify things a little bit, is I'm going to use parentheses, much like you would have used parentheses for grouping with numbers, and say that it's D1 and D0 are 1, or not D1 is 1. Oh, I'm sorry. That should be 1.
So is this just different titles?
I just made that.
So is this just different titles that you could label this black box as?
I believe that all of those 3 rows are saying the same thing. They're logically equivalent.
That's what I thought.
Yep.
Can you verify if this is that? I got a weaker.
Yes. D1.
Oh, sweet Jesus, stop it.
Yeah.
Stop.
Not D1. Or yes. Yep.
Oh, hi. How did I end up in Narnia? Jesus.
The one
Oh, yeah.
D1 is exclamation.
Oh, thank you.
You know,
Not D.
I kept-
no,
I kept doing
first
that.
of all, I noticed it a little bit ago. I just,
I noticed that when he typed it, I just didn't say anything.
yeah, so did I.
You're just gonna let me do that?
Yes.
Gosh.
Yes.
Oh. So again, I think what I'm suggesting, not to belabor the point too much, but oh, stop that. There we go. Okay. I'm using not D1. It's 1 in place of D1 is 0. I'm using the not there to invert D1 so that I can speak of it in terms of a 1 value, not a 0 value, because 1 is my preferred, and I want everything in terms of preferred. Or, and then I guess what I could do is so that's one operation. Higher precedence, I do that before I do the or. Here's my other one of D1 and D0, and they're 1. So now again, everything is in terms of preferred.
Because you're flipping the 1 into a 0.
Yes.
And then the D1 and the D0 are 1. So.
Yep, exactly. And then I'm just going to go shorten it a little bit. I'm going to say, well, okay, if I'm always speaking in terms of is 1 or are 1, why do I need to say that? I'll just drop that and say not D1 or D1 and D0. Because I'm expecting both of these to evaluate to 1. I just don't have to explicitly say, oh, it's 1 all the time.
I definitely understand it better now.
Great. Enough that you think you could try it with a couple of others?
Yeah.
Yeah. So just, change these up to something that we haven't done already, some combination we haven't done already. Give it a shot and see if you can come up with a logical expression for it in terms of nots, ands, and ors, with 1 being preferred.
Is there a circumstance where you couldn't really find 1 being like a
No.
specific? So okay, you're okay. There's one there.
No. Because again, back to my original premise, at least what I've said so far, I realize I have to prove it to you. Make me prove whatever I say. Don't just blindly trust me. I think I've said, I don't know where it was, if it was in here or not, but I reserve the right to lie to you.
It was not in here, but it was here
No, it was.
earlier.
I remember you
So
saying
just be aware that that's my right, that's my privilege to lie to you, just to see what happens, kind of thing. That so if if I say something that sounds off,
Well, how am I
make
supposed
me
to
prove
know
it.
if it's off?
It's just a vibe, a feeling you get.
Fair.
Like you're feeling like makes sense now, right?
Yeah.
Okay.
So are you
Um,
gonna lie to us when we know whether you're lying to us, or are you gonna lie to us while we're still dumb?
Fair enough. That's a good question. No, I would only do it after I thought you should know.
so then we can figure it out on ourselves, like by ourselves.
Yeah,
and we should
like
know that.
now, I would feel well within my right, and I might actually, now that I'm thinking about doing it, to give you another truth, to give you this logic, this truth table, with that combination, say, yeah, this is a description of this truth table, right?
It
No.
wouldn't be anymore.
No,
Or actually, when everyone asks the question, like, right, I'd say, okay, here's the logic, here's a truth table for it.
No.
And you'd be like, no. Yeah. Okay. So I would, again, I strongly recommend, try some others. If you're the least bit unconfident about it, ask. It might be fun to even try some and, challenge each other. Try one, come up with some logic, come up with a truth table, post it in Discord. So the rest of us can either agree or disagree. And you can lie too. I'll allow that. Okay. I'm feeling good about that. Hopefully you are too.
A lot better now.
Good. So then what I'm going to do
he's
is,
gonna change it all up on us.
no, not really. I don't think so. I'm going to steal Cam's thunder.
Oh,
Or yes, because I'm going to come over here to, where's my circuit breaker? There's my circuit breakers. Okay. So I can keep an eye on what's going on over there, and I'm going to come over here so I can see that truth table. And I'm going to implement this. So we have two inputs, a D0 and a D1. So I'm just going to copy those, paste those down here. We have an output. Sorry. I'm going to copy that. Circuitverse, you'll get, it's a little quirky. Like when you copy and paste, it'll paste something right on top of each other. It doesn't offset it like a lot of programs do. And the bad part about that is, forewarned, if you paste like a gate or something on top of another one, it'll make the connections too. So it always catches me, and at halftime I forget, oh, I need to Control C, move the mouse, and then do Control V. Okay, great. So the question is, and yeah, you'll get used to that too. It's actually, I don't know if you ever get used to it. It's the heating system here banging around. Okay. So the question now is, can we implement this? Can we make this black box?
Yes.
And Cam says, yes. And he can prove it.
Sure, we can. I just don't know which of the gates in the corner is the right one.
Ah,
We'll tell you.
well, let's look at our logic here. We said, it won't let me stay highlighted. That it is not D1. Well, there's a not, so we need a not gate. So let's grab a not gate. Or something. Okay, we're going to need an OR gate. D1 and D2, so we're going to need an AND gate. There's our logic. And the question now is, how do we connect them? Well, we said it's not D1, so let's connect D1 to the NOT input. Or, so the output of that goes into our OR. or D1 and D2. So D1 and D2, they both go into this AND gate. D0. Yeah, I meant that. No, I didn't. So this is the NOT of D1. This is the AND of D0 and D1. And the OR is either the NOT of D1, this, or the result of D0 and D1. And that's the complete expression, so that becomes our output. And yes, I could twist things around. I could lessen the number of connections and so forth on that. That's just something you'll get used to. But functionally, let's test it out. So the first row is 0 with 0. D1 is 0, D0 is 0, and I should get a 1 out, and I do. The next row is D1 is a 0, but D0 is a 1, and I should get a 1 out, and I do. Row 2, 0, 1, 2, is that D1 is a 1, and D2, or D0 rather, is 0, and I should get a 0. Oh, and I do. And then the last row is D0 and D1 are both 1s. I should get a 1 out, and I do.
Not equals a triangle with a circle at the end.
Questions, comments? Is
I'm just trying to draw them. Is the and one is the half circle or the arrow?
oh,
I'm just wondering.
This is
I am. Do they have names on them?
If you put your mouse on it, it will
okay.
tell you.
Thank you. I am on the website. I just was trying to draw them so I remembered for later.
Yeah, that's fair.
And
yeah, and
is the
We
half
have to
circle.
start with this on paper before we get it on the computer.
and you're absolutely. I should have said something because I'm just used to. We use these symbols all the time. In the world of digital logic, people just know these symbols.
Does the or
Oh, go ahead.
Sorry. Does the or change between exclusive and inclusive or no?
Yes.
Doesn't matter.
Yep. So we go over here to our circuits. The one curved line up here, that is an OR, which again, by default, is the inclusive. When you have two lines, that's the exclusive OR. There's two curved lines in the beginning.
Okay. May I call the inclusive gate an IOR or is that something else? Like an IOR for inclusive?
Yeah, I see what you're saying.
Is that
Can you do
allowed?
it? I don't think it's going to conflict with anything really. So you can do it.
It's called an OR gate, though.
But yeah, most people that are experienced with this stuff will wonder what you mean by IOR.
I just meant for,
Actually,
like my drawing.
and because
Who knows,
again,
whatever gets in your brain is fine.
but yeah, most developers in this field have done it enough that they've ingrained it in their head that, or if you don't say anything else, it's inclusive. Okay, so now, how are we feeling about that? Lost a little bit of ground. Okay, it's not quite as firm as it was.
It's just the actual logic of implementing it.
My head hurts a little bit.
Understandable.
If I mess around with it a little bit, I'd probably understand.
That is always the case. The more you do this stuff, the more it sinks in. The more, yeah. So if you take more time and play with it, it'll. Should I go on? Can I go on?
I guess I'm ready.
Because I'm thinking just another example will help. And again, what I have said, check me on that. I said that the not the and the inclusive or are our three fundamental gates. Everything else we can build with those. Now, if that statement is true, that means we can build an exclusive or out of nots, ands, and ors. So it's really commonly used, enough so that people just sometimes thinking, like we even notice in circuit verse that they have an XOR gate, exclusive OR gate, but we're not going to use it. I forbid that gate from being used.
Okay.
And so what we're going to do is we're going to roll our own. Okay? How do you want to do it? What is the logic for the exclusive OR?
Hold on, I'm gonna brute force.
The logic for the exclusive OR is that it has to be a 0 or a 1, or a 1 and a 0.
Okay? Now,
And words
remember what we did over here?
Yeah.
So how do I say that, but only using the labels in our three gates? So only using D0, D1, not and an or. And if you want initially, you can throw an is or are in there too, but we should be able to get rid of those. Okay. Do we know what the first step is yet? Hint, I've been suggesting that we prefer one of these values. Okay? And we've agreed we're going to prefer 1. So what I need to, all I need to do then is worry about these two cases where I get a preferred. Because if I don't get a preferred, the only other alternative is you get a 0, the others kind of fall away. So now I've got two cases where I get a preferred out. I get this case, which how do I express the inputs for this case?
I'm really trying to work this out in my head.
So would we always want D1 and D0? This is a little not necessarily around the naming scheme. It just popped into my head when I was trying to figure it out. Say we were trying to make it in circuit verse. Never mind, actually, I realized I was wrong. I was gonna say a lot of the time we would want them to both be connected to a knot because we want them to be opposites for this one.
I think you're onto something.
But then I realized that because if they were both the same, if D1 and D0 are both 0, for example, they would also both be 1 if it were, simple as that.
No. Okay, so first of all, stop that sorry thing. Secondly, I love the fact why it's good to be together like this and be with other humans and so forth, because as you're talking it out, as you're speaking, you're realizing like, oh, wait, that didn't make sense or whatever like that. So there's great value in being with other people and saying things out loud. And you'll confirm it in your head or not, kind of thing. Additionally, yeah, you're on a very good track of something. Okay. The fact that since the inputs are all 1s or 0s, and sometimes they're a 1, sometimes they're a 0 in different cases, kind of like that. What if I just initially said that I have D0 and not D0, and D1 and not D1? He's like, that's what I said. I'm like, yeah. So if I did that in my logic, if I was implementing it and I did that as a matter of routine, I'd be set. I don't have to always do it. And sometimes I might not use one of those, but it doesn't hurt. And I will definitely do that going in the future.
So just for the naming scheme, could you do you could, realistically, could you start with either one because they're flipped with how it's worded? Like you just have to pick one and then go with the logic from there, and it would just be flipped from the other way you could do it, I guess. Like, for example, if you're starting with D1, the second one, it would be different than if you were starting, or if you like, if 0 was D1, right? It would be different from the naming convention if you did 1 as D1. I'm just having trouble with that.
Okay. The thing that was in my head was, I probably would not. What's that?
I probably worded it horribly.
That's it. What I would not say, the way I would not word it, is I would not say 0 is D1. I would probably never say that. I would say D1 is 0 or D1 is 1, but I wouldn't say that the value is the label. I'd say the label is the value. I'm not sure if that really helps or really addresses what you were getting at, but but that was a clarification way we say it is, in every case, D1 has a value. In every case, D0 has a value. It's a question what the value is.
Would it be D1 is not D0? Because they can't be the same.
Yes.
I just for the name, I can't put it into the.
That is true. That we only get a preferred when they're different, and that's a use for it. One way we can use this is to say, okay, are the two inputs the same value or not? The exclusive OR will tell us that. But you're not telling me what the value of D1 or D0 is, because that works for the middle two cases, but it doesn't work for the other case. And I've got to have something that while I said we only have to focus on the two cases where we get a preferred out, we have to be complete enough that whatever we say is not true for the other cases.
Is it if D1 and D0 are both 0 or both 1? That's how you get 0?
That is true. It is true.
No,
But the problem is, again, you as well, you're being too human. Stop that.
Okay.
Let's go through one at a time, because that's what we did over here, right? Okay. But this time, I only have these two cases to worry about. So let's start with, now it doesn't matter whether you start with D0 or D1. I will agree with that, okay? But let's start with D1. And let's start with this case. So what can we say about D1 in this case?
D1 is not 1.
No, because D1 have two.
Yes, but I'm going to start simpler with what it is, and then we'll filter that out. That's it. D1 is 0, right? D1 is 0 in this case. And D0 is 1.
Oh, you're doing the
I'm doing the second row here.
Sorry.
Because it doesn't give you a favorite output.
You mean row 1?
Yes. Touche. You okay with that? I'm looking at just this row right now where I've got a preferred, the first row that has a preferred output. And I'm saying D1 is 0 and D0 is 1.
Then just do an OR. Flip it.
So that takes care of that row. Now I need to look at the next row that is a 1, and I'll say, okay, it's either that case or, and let me do this just to clarify.
Would we do parentheses? Okay, yep, never mind.
Yep. We'll find out when they're necessary and when they're not. Remember order of operations in math? We do multiplication before we do addition, kind of thing like that.
Would the
does
end
it-
bracket be after the 1?
I'm sorry, say it again.
D1 is 0 and D0 is 1. Would the end bracket be after the 1 instead of after the D0?
Oh, yes, yes. Yeah, thank you. In fact, yeah, yes, yes. What I was going to say was, thank you, George Boole, who was a mathematician, logician long ago, who is why we have Boolean algebra or Boolean values. Okay. No. You can catch the video later. The rest of it.
Yeah.
Are you feeling good about what we're doing so far?
Yes, I am.
Okay, that's the key. Yep. So I understand completely. Do what you need to do. You too.
The next one is D1 is 1 and D0 is 0.
Okay, yeah, I'll save the George Bull speech for later. Okay, so this is the first case where D1 is 0 and D0 is 1. We get a preferred. Or in the second case, if D1 is 1
Oh,
and
algebra. Sorry.
You will. It's coming. Don't worry.
Yes.
And D0 is 0.
He's gonna change math by teaching us math, but different.
It's numbers. It's logic. It's but yeah. Okay. Are we agreed with that so far? That this logical statement summarizes the truth table accurately, completely. Now I want to, I don't know, maybe simplify some things, or at least I want to be able to express everything in terms of my preferred value. So if I have a 0 here, and I think I have one over here, yeah, I have a 0 over here and a 0 over here, I need to get rid of them.
I would call it D0 and D1 cannot be. That's what I would say for my next. That's simple as they can't be.
Okay.
But is that too human?
Yes, is that
Yes.
human?
You're still, yes.
Okay. Then what is the right thing?
Could we say something like only one input must be 1?
What about D0?
You could, but that's a bit human. No?
D0 is 1. But then
So this part's cool. I'm cool with that. D0 is 1.
D0 is 1, and then would you do or D1 is 1, but then that leaves the other two. It leaves the
I wouldn't. I would say not D1 and D0. In other words, if D1 is 0, I'm going to use a not to turn that into a 1.
Okay.
yes.
And D0, which is a 1, I've just dropped the is a 1.
Doesn't that leave room for it to be neither?
That itself does, yes. But we're not done because we've only done one half of the OR.
Okay.
But that's a great insight. This alone, if we stopped here, that would be like this truth table.
Right.
Would you just flip it again when you do the or?
So whenever, and if you think about back over here, that's what we did. Whenever we had a 0, we knotted it. Because if you knot a 0, it turns it into a 1. So over here then, it's that case, or now I'm in the next row, I'm in the third row down here, or row 2, where I'm saying if D1 is a 1, so I can simply say, okay, D1 and D0 is a 0, so I'll say not D0.
Because you always do it in terms of the preferred number.
Yes. Yeah.
That makes sense.
And now we just have this little rule pattern. I don't want to call it a trick, but we have this way of turning ones into zeros and zeros into ones with a not.
I wrote not D1 and D0 or not D0 and D1. Does the not have to be second, or does that make the whole thing a
No, and the order doesn't
Okay.
matter. So
I wasn't sure because I
Yep,
know
no, it's-
like in math it doesn't matter, but I didn't know if this version of it. I know, but we said algebra earlier, so that's where my brain went.
oh no
I
no no
know
no,
in
you're fine. You're fine.
algebra, It doesn't matter, but I didn't know if in this version of algebra it did matter.
You are fine. You're perfectly good. I'm just getting excited here because I want to formalize what you're saying.
Yes.
Okay, and you're like, how can I do that? And I'm like, you will recall that when you learned algebra, when you learned arithmetic, not only did you learn order of operations, okay, but you also learned about these properties such as commutative, associative, distributive.
Yeah, I remember those.
Yeah.
I mean, they're not the worst thing in the world, but they do kind of suck. I'm not gonna say.
It's one of those things that it's foreign at first. It may not be very natural or intuitive, but you learn the rules, and after you use it a while, kind of thing, it kind of starts to make sense, and you solve a number of problems, and you see why it works and why it doesn't work. But addition is commutative. Back to that George Boole and that Boolean algebra thing. When we get there, I'll say a little bit. I'll at least give you the spoiler. That the AND operation is essentially multiplication.
For multiplication, you can
The
switch them and
OR
it doesn't matter.
The OR operation is essentially addition.
And what is not, or does it not matter?
Not is like negative.
Okay.
I did it.
And it's addition.
It's only easy once you spell it out.
Or
So do you want to do it? You want to see an example?
you said and is addition and or is multiplication? Did I mix that up?
Flip the other way.
Okay.
OR is addition. OR is Boolean addition, and is Boolean multiplication.
I like the
And
idea of this whole
so
thing.
now I've got to do it because the only way it's ever going to make sense is if you do it and see it and play with it. So what if I said 0, 0. Oops, did not do that.
Oh, I don't want to connect those.
Oh.
I
Okay.
tried doing it in circuit burst and it didn't do the thing that we wanted it to do, so I don't know how to fix it.
This big machine is the same as that little one.
We'll do it together in a minute.
Okay.
But I applaud you for trying it. Okay.
That's what I did. I know that's not right. I just don't know what.
That's just an OR gate.
Yeah.
So
I love your faith in me. I don't have that kind of faith in me.
I wanna help you do it, 'cause I think you could do it on your own.
0 plus 0 is what?
0 plus 0 equals 0.
0 plus 1 is
0
1.
plus 1 is 1.
1 plus 1 is
1 plus 1,
I mean, 1
or 1 plus
is
0
1,
rather,
and 1 plus
is
1
1.
is 1 in this sentence, but that would be 1 plus 1 equals 2.
Okay, now
'Cause we can't
bear
have
with
two.
me on this one a little bit. Okay,
We have one.
you want to say that that is 2. I will allow that for the moment, and then we'll figure out why that doesn't work, or how we should say it.
What's 2? I've never seen that number before.
It doesn't exist in this world. In binary, there is no 2.
I know.
So we can't do that. But wait a minute, what happens instead?
Would it be 1?
I think it could be 0.
Why would it be 1 or why would it be 0?
I believe it'd be 1 because it's still, there's still something there.
Okay, you know what? I'm gonna,
Because we're not doing math right now, we're doing a black box. And we're
one
saying
of-
this is this. We're not saying the number 1 for math plus the number 1 for math.
I'm trying my best here to demonstrate, to show, to prove that math is math.
No, math is not
Math is logical. And we're going to get the same results. So, but again, bear with me. Oops.
Oh,
Oh,
it probably is.
yeah, I like that better. Thanks.
Oh,
Okay. 0 times 0 is what?
0.
0 times 1 is what?
0.
0.
1 times 0 is?
0.
And 1 times 1 is what?
1.
Okay. What if I replace those times, that x, with and? There's our and gate. Right? The only time I get a 1 out is when I put 2 1s in. So there's my proof that Boolean multiplication is essentially an and, or a Boolean and is essentially multiplication.
Wait, so then the additional would just be an or?
In addition is an or,
Yeah,
yes.
because the 1 plus 1 would equal 1 because there's still.
So 1 and 1 is 1.
Yeah.
If you're okay with that, I'm going to go with it for now.
Am I wrong?
Again, it's not a question of wrong, it's a question of completeness.
Or they're turning it into not C's.
Ye- Okay, here's the way about this. I am thinking in terms of binary, base 2 algebra, arithmetic. You are thinking in terms of base 10, because it's what you know and what you're most familiar with. One of the other generalities that was probably not pointed out to you when you learned how to count was that all the rules of algebra, counting and algebra that you learned apply in every single number system out there. The only thing you are allowed to change is the base of the number system. Of course, that begs the question of what does the base of a number system mean? What does it tell you? Why is base 10 base 10? Why is what we call the decimal numbers, why are they base 10?
Because there's 10 characters, 10 values.
Exactly. You have 10 numerals.
That's
10 numerals, 10 symbols to work with, 0 through 9. Okay? If we go to any other base, then whatever the base is, that's how many symbols you have to work with.
So base 2 would be 0. and 1.
So base 2, you only have 2 symbols. If we're using 0 and 1, and this is why people think this, why 0 and 1 is convenient, because mathematically it works. But what happens in base 10, decimal system you know and love, when you want to count past 9?
You have to add a second.
Combine the numbers to make a difference.
You need 2 numerals to do that. You need to start thinking in terms of place values. Okay, you've used up your ones place, and now you need a tens place.
Mhm.
You carry your 10 from the ones place over to one of the tens place. And that's what's happening here. And we're saying 1 plus 1 is 2. But again, there is no 2 in binary. The real answer is
What do you think?
it's 1, 0. One twos plus 0 ones.
I don't like that answer.
I think I get what you mean by it's partially correct now.
Yeah.
It's like if you showed someone who lives in a 2D world the third dimension.
Mhm.
Yes. Are you familiar with Flatlander? The book Flatland?
No?
Oh.
It's
Uh,
like trying to explain to somebody who doesn't have the, like in a world that doesn't have the world group, a group of horses, and that is called a group. You need to figure out how to. It's also like describing. You describe to a person a dog if they've never seen a dog, and then ask them to draw it. You're trying to explain to them so that they understand how to draw a dog.
mhm.
Why do you have 1 plus 1 equals 10? By the way,
It's not 10, it's 1, 0. Were you not listening?
no, I didn't see you write that up there, so I was still trying to do everything on here, so I didn't see you write that up there. I was listening. I swear. I
If
didn't
it
see you
helps,
write that.
I'll do that.
Thank you.
Okay, you move that over
Sorry,
there.
I was.
No, don't be sorry. And
He hates it.
and
Yes, I know. I apologize.
yeah, don't be sorry. And Cam is just picking. We're having fun with each other. There's no animosity in
No,
here.
I just didn't see you write it.
Obviously, that wasn't 10.
No, because we were just talking about base 10 versus base 2, and
Yeah.
I was listening. I didn't see you write it up there.
And admittedly, I made some statements. They may land with some people, but they probably haven't landed with everybody. Probably ought to clarify things a little more. So I'm going to do that. Okay? And we'll just put a bookmark here. We'll come back to building our exclusive OR out of nothing more than knots, ands, and ORs. But this is incredibly valuable stuff. Cam?
See, now I have a problem because I don't remember ever learning that. I remember that 1 plus 1 was a single digit and it was likely 1.
Yeah, I think it's probably because of that thing where you learned, somebody taught you the easy patterns or the recipes kind of thing without really explaining why. Just like you learned all about base 10, nobody extrapolated that to say that, oh, it applies in every other number system. You only change the base. Now let's go through some examples of changing the base.
Nobody even mentioned the other numbers.
And yeah. Now, I guess in all fairness, elementary school teachers have to, they're probably worried about overwhelming you. And although I personally think that children are more resilient than we give them credit for, it may overwhelm them, but it may challenge them. They'll work it out. It's better to give the knowledge and then work it out than to try to hold it back. But that's just me, and that's my educational philosophy, and probably why I do not teach K through 12. All I will say is that I would like to think that my daughters, I have 2 daughters, that are fairly well adjusted, even though they put up with me. So, anyhow, because the other thing is, I will argue that there is really only one thing that you ever do in math. That 4-letter word math, it freaks people out. There is really one primary operation. Do you know what it is? I mean, you do. But
Addition.
no, it's more basic than that.
Count?
Counting. Exactly. Because what is addition?
It's adding two numbers. It's counting the sum of two numbers together.
Yeah. Okay. I would say that addition is repeated counting
Oh, yeah, repetition.
because what is 2 plus 3? You count to
Five.
1, 2, then count 3 more. 4, 5. So, yeah, addition is repeated counting. Think about the manipulatives when you're hopefully when you're in school, you got the little blocks kind of thing, and you put 2 here and you put 3 there. How many are there total? You count 1, 2, 3, 4, 5. What is multiplication?
It's
I just assumed because
It's
you can
the-
get every other operation with just addition.
it's the adding of the same number however many times. So like
Yeah.
3 times 2 is 6 because you're adding 3 plus 3. You're adding the base number as many times as the other number
So
quantifies.
multiplication is repeated addition. What is exponentiation?
It's-
Repeated multiplication.
yeah, it's a-
We just keep building up on it. By the way, what is subtraction?
It's adding a positive and a negative number.
it's taking away.
Yeah, counting backwards.
I was gonna say.
And what is division?
It's massive taking away.
This is good because earlier when I talk about fractions and people were like, but what is division really?
I mean, division is really just a fraction line, but like the line is like a fraction, but it's
Mhm.
still,
Do
Yeah.
you notice a pattern? So I said
Yeah.
that counting is the basic operation. Addition is a shorthand, a nice, more easy way of thinking about repeatedly counting up. Multiplication is a shorthand, making it just easier for us, right, of repeatedly adding numbers together. So if subtraction is counting backwards, then what is division?
It's repeatedly counting backward. Repeatedly,
Subtracting, yes.
I was gonna say, I know it's not like you can't use the word divide. That's where my brain went at first, because that's bad. But yeah.
Well, no, it's not. That's the way you've been trained. But yeah, if multiplication is repeated additions, division is the opposite, the inverse. It's repeated subtractions. Now there's a fun one, because we took that a step further. We said, oh, exponentiation is repeated multiplications, which means there ought to be an inverse relationship of that, which would be repeated divisions.
so that's square root.
What do you call it? Well, square root is a particular case. That's when you divide twice.
Yeah, that's different.
It's a special case, I would say, because then you could do a cube root. Well, that's 3
So
divisions.
roots.
Roots. I would say roots. In math class, you learn roots as being a little bit different, the definition kind of thing. So just be careful of that. But yeah, I would say if exponents are repeated multiplication, repeated divisions are roots. It's the inverse relationship. You're saying, okay, x cubed, or let's say like 3 cubed means I have to multiply 3 3s together. So what's the root of that? What's the cube root of that? Kind of like that? Oh.
Yeah, I didn't think of
9
that.
divided by 3 divided by 3.
Give you, like, a 1.
Okay. So assuming that your brains are still kind of fluffy and let's do this. Let's do. Was that?
This is fun. I'd rather be here than playing Fortnite.
That's it.
Really? I'm glad to hear that.
Tell Professor LeBounty this is my math credit. I'm kidding. I have been for math.
Well, earlier
It's my math credit.
earlier I was saying that we should get philosophy credit for this course. I think we should get math credit for this course as well.
Should, like a
Um,
I don't need to take statistics.
In fact, actually, I would say, let me do that. My dream is this is the only course we ever have. All we ever need is one course. We do everything in it. And you just take it again and again, doing more and more and more. Deeper and deeper and deeper.
Yeah,
So
why
how are you
don't,
gonna
why
get
can't-
nursing out of this?
Nursing, there's got to be some fundamental thing that you learn in nursing, right?
I mean, you
I don't
do
know, I
have
haven't
to know the
taken it.
math of like, I know this isn't math, but you have to know how much of like the medicine to give a child or versus an adult because of different like age, weight, race, gender, stuff like that. All that stuff can change how medicine reacts in your body.
Mm-hmm.
And I don't know. I'm going somewhere with this, and I
Oh, believe me, I understand. But I would say, yeah, there are some basic things that you need to learn in nursing, and then the rest builds upon that. And then you just keep building your skills, introducing a few new things, practicing the things you've done before, kind of thing. So I think it could be handled the same way. You want to be a nurse? No? Oh, okay. Well, then I guess that ends the conversation. But if you did, I would have pursued this further and said, well, okay. Because here's the thing. Should a nurse know how to count?
yes.
Hopefully. Again, that whole medication thing, kind of like that. Should a nurse be able to manipulate numbers? Again, dosages, medication stuff, sure. Should a nurse know how to use a computer?
In this modern age, yes.
It is better. Yeah, you go into hospital these days, and yeah. So yeah, I think that it could apply to nursing as well. Okay, I'm going to start counting. Are we agreed that we should really start counting with 0? That you have nothing before you had 1?
Yeah.
Do you realize, by the way, that's a relatively young concept in mathematics? 0 as a number has only been mostly agreed upon for, I think, around 400 or 500 years.
Why would it not be?
You don't count because
What would you count from nothing?
It's not like
nothing is not a number. It's you either had 1 or more. Because before people really had numbers, it was simply 1 or more.
they would have nothing. They either had it or they didn't, but they didn't.
If you didn't have
quantify that
anything,
as
who
a
cared?
zero.
It only mattered if you had something, if you had 1 or more of something. So if you look at like the Ishango bone and some of the archaeological evidence of when people started to count, by keeping tally marks on a bone kind of thing, there's strong evidence that, yeah, people didn't count like we do. We think it's intuitive. We think come on, everybody knows how to do that, right? No. For most of our history, people didn't count like we
To
do.
be fair, if you're told count to 10, you start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because why would you start with 0? Because it's obvious that you don't need the 0 unless it's specified. So in that sense, I guess that makes sense.
Yeah. Also, by the way, there's very strong evidence that older cultures like the Babylonians used base 60.
60.
Base 60.
That's special characters.
Not base 10, not base 2, base 60. And we
don't have that many letters in our alphabet. We don't have
That's
that many
right. We've only got
characters.
24 letters. That's all we need. They would have needed more, right? Okay. Where did the concept of 60 minutes in an hour or 60 seconds in a minute come from?
Is that base 60?
Base 60.
I've never known for sure. That's why because I never understood why this will come out wrong.
Mhm.
I understand like the 12 months in the year, even if we've got like the extra 2.25 that gets us to leave here every day. But then why didn't we do like every month having the same amount of days and however many days were left just put into another month?
Yeah.
If that makes sense.
Why didn't we, if decimal is such the
Why
great
30
thing,
to be
why don't we,
30 and 31? Like, why did we
Huh?
decide some months get 30, some months get 31, and then February gets 28? Why did we decide that? Or ancient Romans, I think it was the Romans. It was
so,
Julius Caesar.
oh gosh,
Sorry.
calendars are a fascinating subject. Yeah, we operate sort of mostly on like a Julian calendar, but there was a Gregorian calendar, and why, and all this stuff is ultimately based upon astronomical observations, and that's why we end up with some of those things like that. But if everything was decimal, then why wouldn't we just have 10 months? And he said, however many days there are in a year, why not just decide that there's 100 or 1,000 or maybe 300 or 400 days in a year? Why not just divide those evenly amongst 10 months?
Well, I
Doesn't
mean,
mean year's supposed to be a cycle.
a cycle is
Yeah.
it's the amount of time it
You-
takes the Earth to go around the sun.
Right.
But if it wasn't until like the 1400s, I think, that we started to figure out that the Earth, because we used to believe that the Earth was the center of the universe before we started into astrology and figured out that the sun is the center and we were around it. So that would have made that like the year after that they like kept. We had the things like the sundial though, so I guess, but that gets you time. That doesn't get you the amount of days unless somebody was keeping track of how many times does the sundial go. But
What-
even then, how do you know when it stops?
What are the graduations on a sundial?
It's like a clock. I don't know enough about
Yeah,
sundials.
the
to answer that
marks
question.
and the spacing between them.
I don't know. I'm
Because
is it
you're gonna-
is it the 9? Is it the 12, 3, 9, 6, 9? Jeez, I can't. Okay. Then I don't know.
Because again, you're
Sorry,
thinking,
I
oh,
don't know.
decimal, everything is decimal, right?
Yeah, I don't know.
Why are there 24 hours in a day? Because I'm taking a shortcut here because I was doing the year thing and you were like, oh, there's 365 days in a year. I'm like, well, why are there 365 days in a year? The year is the time it takes for the Earth to rotate around the sun. And there's 365 units in there. That's only because there's 365 24 units in there. Days. 24 hours. But why is there 24 hours in a day?
That's all it takes from when the sun sets to when we're doing it right.
Who says? Who measured that?
Wasn't it like 12 hours?
People.
It's like, it varies a lot depending on the day.
And it does vary over time, yes. There's nothing magic about the 24. 24 hours. And you're like, oh, it's 24 hours because it's 3,600 minutes. Like, seconds on that. But who said how long a second is? Do you know how long a second is by standardly? What's the modern definition of a second?
60 seconds. Oh no.
No, 1
Second
second.
is 60
Oh,
seconds.
sorry. No, I thought you meant a second is 100 milliseconds.
Okay, then what's the definition of a millisecond? I know it's 100. It's 10 microseconds, yeah. But what's the definition of a second? No matter how far you divide it down to.
The smallest
How-
form of measure.
How come our clocks are all in sync? Well, supposedly. Okay, go ahead.
Oh, my clock
If
is
you're-
in sync with your clock.
Yeah, because yours is a few seconds faster than mine.
Still very slightly, but they're pretty
But,
close, and that is
If
because
you're talking about like the universal clock, they go off of. Doesn't it go off of like the?
Every night.
There's just like one clock.
Yeah, there's the one
Like-
universal clock that they could deal with down in. I'm thinking like Antarctica at the 2 poles, like when the expedition's down there, they've got like a universal time, and that goes off of the Earth's gravitational pull and its axis and stuff like that going around it. There's a way to track it. I don't remember how they did it. I've heard it explained once, but I don't remember exactly. There's a thing. Stop it.
So I believe you're talking about time and time zones, which again is a whole other
I know,
fascinating
I'm
thing.
saying, because they didn't have to
and
worry
you-
about time zones. They go with the universal time zone, which is a
Yeah.
different can of worms.
But that's still eventually I'm going to come back to the idea of, well, okay, regardless of what time zone you're in, a second is a second.
Mhm.
And what determines how long a second is?
A second.
Someone who
and
doesn't
we have
know
this-
what they're talking about.
I don't know.
We have this notion of an atomic clock, which is based upon the molecular resonance, the atomic resonance of a cesium atom, a particular isotope of a cesium atom.
I don't know who decided that. People centuries ago that have really
It's not the same
important
people who made the
and
metric system.
Why can't a second be first?
Why can a second be what? Did you say reversed?
First.
Oh, first.
no, he said why can't second be first? Alan,
Uh,
I don't know. I don't know why
sorry.
second is a second.
no, but does anybody here happen to know who Abbott and Costello are? It
I
does.
don't know if I know who that is, but I might know who that is. I have this stupid thing where I could tell you things like if I've heard it, but I couldn't tell you who did it.
They were a comic duo.
Oh, is that
And
the
you want to
Who's on-
explain the relationship?
Oh, is that
the
Who's on
relevance?
First show?
I can't really explain it. I haven't seen it in a while, but my
Is-
dad was obsessed with it, so I had to see like.
Is it the Who's?
I'm sorry, am I bringing back bad
Is that
memories?
the Who's on First?
Yes,
Also-
yes.
okay.
Who's on
I
first?
know
Yes.
I know about it because years ago I was in marching band and our theme that year was baseball, and so they did a little skit about who's on first, what's on second, stuff like that.
I
Yes.
saw
So
Who's
I
on
know
First
of
on
it.
TikTok, and now I'm obsessed with it.
Yes, I know who's on first.
Okay, so yeah, that's
Sorry,
whew.
we got sidetracked a
What
little
were we
bit.
doing?
We were about to count, and
So we're counting, and I was just making the point that units. We determine what they are, but some units are grounded. Well, hopefully all measurements are grounded in something. There's some kind of standard, but it may not be what you would think. And it's developed over the years because why is the imperial unit of length a foot?
Because of the king's foot. at some point.
Exactly, yeah.
and
But
they had to remeasure
every
every
king
time.
has a different foot
Yeah,
size
so
kind of
they
thing.
had to
The
remeasure
king's
it
foot
every
size
time
varies a
something
little bit from day to
died.
day. So okay.
I remember
Anyhow,
that.
let's do something easier. Let's count. Okay.
2, 4, 6.
Oh, that's where this whole thing started.
Yeah, that's what-
We're going to
so
start with
talking
zero,
about
right?
zero.
We're going to start with zero because we're going to treat zero as a real number like all the other numbers, even though there are some mathematicians that to this day will argue that zero is not a number. And it's only been within the last several hundred years that we've treated zero as a full-fledged first-class number. Okay, which is why a lot of people start counting one. Okay, yes.
What would it be if it wasn't?
It just wasn't a number. There's nothing. It's back to that idea of
That's it, there's
Nothing-
zero,
nothing-
zero.
nothing is not a
Dwarf
number.
planet,
One,
the
you-
actual number is what?
what's that?
I said if Pluto can't be a planet, they called it a dwarf planet. So
Right.
if zero is not a number, does that make it a dwarf?
A dwarf number?
It's
I love
something-
that.
it's
I
an
love that.
absolute-
I think we should try to,
Zero
get that
is
out
an
there.
Absolute zero. That's what it is.
I think it should become our mission is
Absolute
to,
zero. There's zero Kelvin. There's all the different things. Why don't I? Oh, I know what that is. It's garbage.
Oh, okay. So, and my rule here always is when you're dealing with number systems, so you're not familiar with them, always, and this is actually problem solving in general. I know it's not problem solving, I know it's essential, but always go back to what you know. When you're stuck on something, go back to what you know and work from there. Okay. So we are most familiar with decimal, base 10. So if you're ever stuck with on a number system issue, go back to what you know, base 10. And what we know is that base 10 has 10 numerals. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Which, by the way, I don't mean to sidetrack us again, but those are the symbols we use. Other cultures use different symbols.
I knew that.
Okay, and so because we only have 10 symbols, what do we do when we want to count one more?
We add a second.
Find the first two to make it a new number.
Yeah.
Okay.
So you get 10.
But I need two numerals.
Okay.
one number with two numerals in it. Where do I get the two numerals from? I suggest that what we're going to do,
Well, if you think about it, because they're, so we've already used 0 for the first 10, because technically there's a 0 in front of them. You just then move on to the next number that you have, which is 1, so then you put a 1, and then a 1 again. And then you go to 1, 2.
that is what we do, but why do we do that?
Because
And
it's
I'll
basic
just-
to make a billion infinite symbols.
I'm going to suggest that an algorithm, a nice recipe repeated way of doing this for any number of numbers, is to think that, okay, I'm base 10, I've got 10 symbols. When I run out of those symbols, I will start repeating them.
Yeah.
And then whenever I repeat, I need to keep track of how many times I've repeated. That's why 10 is 1 10 and 0 is 1s.
So you're counting the times you've counted.
Exactly, yes. Yep. I'm counting the number of times, keeping track of the number of times, counting the number of times that I have run through my symbols.
You're like, oh shoot, I ran out. Okay, I gotta start counting again.
Well, then I can keep adding more place values. Which, by the way, this whole place value thing, I'm gonna do this.
That's what he explains how it looks like.
So this is our ones place. Oh, I did that again.
Counting.
This is our tens place. I'm in decimal. And this is our hundreds place. And I can keep going, right? Thousands, 10,000, so on. Okay. Can I express that in exponential notation?
You would call it 10 to the. You would call it 10 to the whatever. Because 10 to the
Yes.
2 is 100. 10 to the 3 is, I think that's 1,000. 10 to the 4 is 10,000.
Okay, now go
Yeah.
back the other way.
To
You started with 10 to the 2 is 100, right?
Mhm.
So what is 10 to the 1?
10 to the 1 is 10.
What is 10 to the 0?
0. You can't have 10 to the 0. Well, I mean, 10 to the 0 is 0. Oh, no.
Fell into
Yeah,
the trap. You
0.
fell right into the trap.
It's either 0 or it's 1. I
10
can't.
to the power of 0.
It's
You're
either-
not multiplying anything. So
Yeah, so it's.
Mm.
0.
Okay, now you're thinking logically, which I would normally applaud, but that's not the way that mathematicians do it. That's not what you learned in math class.
keep on. So
Ian, I think you're on. What is 10 to the 0?
1.
I was gonna say it's either 0 or it's 1. Now that I was thinking about it, I couldn't.
Uh-huh. So it turns out that any number to the 0 power is 1.
Flip it 1 back.
Why?
That's why.
Because you just said intuitively it doesn't make any sense.
Oh, you can't divide by 0. You can't divide by 0
Why would
because
we
it
divide?
makes.
I like the way you're thinking.
I
I think she's thinking because exponentiation is repeated multiplications.
So if you're going
Roots
backwards,
would-
that's
and
still the,
if you can
that's
do
kind of the division. You
exponentiation,
can't divide by 0 because
You need to be able to do the inverse. You need to divide by 0. Okay.
Yeah, and my teacher used to joke that it makes the world blow up. So every time I think of anything divided by 0, it makes the world blow up.
So I would say that's probably as good as most of the answers you get.
Wait, so should it
Because-
be 10 to the power of 0 beyond the
You got the weird thing again.
I know I did that.
I hate that.
Um,
It's irritating when I was trying to.
We're not multiplying it by 0. You're just multiplying it 0 times.
What I will say for the moment is that I like that answer of how'd you phrase it? The world would blow up or something if it
Yeah,
wasn't?
if you divide
and-
by 0, the world blows up.
Okay. Most of the answers for why any number to the 0 power is 1 ultimately come down to because it makes everything else work. I'm still waiting for a nice intuitive explanation that would satisfy you, like, well, wait a minute, if you've got 0 things multiplied together, you got 0, you got nothing. But it turns out it's 1 somehow. And the best answer you usually get is, well, some proof that if you do that, other things work. And if you don't, if you assume that 10 to the 0 is 0, other mathematical things don't work. Yeah, that dissatisfaction on your face right now should be there, belongs there. Okay.
You're gonna get this guy out there.
So, we can express our place values in exponential notation, the base to an exponent, 0, 1, 2, 3, 4, and so on. Okay. And now, give me a 3-digit number.
152.
Sure.
150.
It's
Oh,
really tiny.
forgot I changed the font on that.
It was just a number I picked as 152.
It's as good as any other number.
Okay.
152. What does that mean?
Nothing. Well, no, it means that you've counted the 0 to 9 15 times and then add 2. Ow,
Ooh.
I just stabbed myself.
15.
Because you get.
What's that?
Well, 15 means, follow your logic.
That's
15 means
15 times that you've counted from 0 to 9 because you needed to go to the next. So that's 15 more
But
times.
15 is 2 digits, so how did you get to that?
I don't know how to explain that one. In this context, I don't know how to explain that one.
because since you're taking the 15, which is in the tens place, that's 15 tens.
Yeah.
So what that's saying is you have counted 10 15 times. Plus you've counted 2 more.
Yeah.
Right? In other words, oh gosh. What you learned way back when is that 152 is 1 100ths plus 5 tens plus 2 ones. You've got
I mean, yeah. But
You've got 1 in the hundreds place, so that's 1 100ths. You've got 5 in the tens place, so that's 5 tens. And you've got 2 in the ones place, so that's 2 ones.
why did you break it like that?
What's that?
Why did you break it like that?
Because that's what it says. Didn't you do something like that initially when you were first learning?
I don't,
About
I
pla-
don't know.
about
I
place
don't
values?
Remember that far?
Yeah, it's the 100s. You get the one. You do the 100. You do the big numbers and the little. You go biggest to smallest. That's the point. You go biggest to smallest, and you start with the 100, and that's why it's the 1 in the 100s because that's 1 100, and that's 5 tens. I'm thinking the little like the orange blocks that you get in like kindergarten. That's how you count. And so you get the 5 10 things, and then you get 2 of the singles, and that's 152 because that is the number we have.
Sure.
I will not
Uh,
explain
I
it.
get that, but how's it relevant?
well, let's do this.
Oh, sweet heavens.
Okay.
That's 101,001. It's 101,001.
Well, it's just 1 and 0.
Oh no, in binary code, that's a that's a
Okay.
different thing.
So if this is base 10,
That's binary, and that's base 2. And
I
that
am
means
now-
something.
switching to base 2 on you. Now you bring up a good point. Let's do this. What base is that number?
Which one?
This one.
That's base 10 most likely.
At least 8.
Really? It couldn't be base 7? Base 6?
don't
Base
think-
5? Base 4?
Do those even
Base 3?
exist? I don't think those exist. If they do, I don't know anything.
They do.
about them.
They
Okay,
do.
I didn't know. I only know.
Which
I know.
is-
I know base 2.
it's
I
at
know
least
base
8.
10.
It's base.
And base 64.
Because 0.
Okay,
could be in
so
there, at least
Think it, 10 is just a number. I just caught myself. Dang, you did it again. Just 10 is a number. We're saying base some number, and that number can be anything. There is an infinite number of number systems positional number systems out there. Again, what's the key to the rule? What's the key rule here? What does the base tell you?
How you add it? Like how
No,
many
no,
numbers?
no.
how many numerals you have.
Yes.
Ah,
How many numerals, how many symbols do you have to work with? Okay. How many symbols are here?
3. No.
3.
At least
No,
8.
go with your first.
Three.
Well, 3, but it's up to at least
Just because
8.
I think what he's trying to say is just because those numbers exist doesn't mean that it implies the other numbers exist.
Oh.
There's nothing.
That makes
There's
sense.
nothing magic about those symbols.
Right, because we've talked about that. It's not different than our rocks and potatoes.
Exactly.
Okay.
Yep. And different cultures
So
use
that
different
could
symbols for that.
be base 3.
So all you can say is it's at least base 3. Now it could be base 4 and they're just not using another symbol. And so it could be any base higher than that, but it could be base 3. It can't be base 2.
Yeah.
Or base 1 or base 0. And I'm tempted to, but I want base 1. What would that be like? What would base 0 be like?
Base one is just one numeral.
You've only got one symbol to work with. What are you going to do with that?
And base 0 is another.
You got no symbols to work with. What are you going to do with that?
Boring, and base 0 doesn't exist.
Exactly.
Okay, so we're in base 2, and again, I'll take as long as it takes to prove that all the rules you learned over here in base 10 apply in every number system, positional number systems. So I'm excluding things like Roman numerals and tally marks, okay, but positional number systems, which means
Tally marks are like base 1.
we can be able to express our place values in terms of the base to an exponent. But that means that the base is going to be 2 now. Okay. And this number I need to keep going because I have 1, 2, 3, 4, 5, 6 positions there. So I need 6 positions here. So let me slide these.
I hate trying to copy things because it doesn't like to copy the whole text box all the time.
You have to get the entire box, including the border, which you can't
so
see.
Then when you make
Yes.
it smaller so that it's easier to manipulate, it's like, no, it doesn't like to cooperate.
What in the world
It's
am I
actually
doing?
quite irritating. What did you do?
I don't know what I
My
did.
least favorite is when you try and click on it and it just draws arrows everywhere.
Yeah.
Yes, you love the arrows. It's fabulous.
And
How are you
the other issue is that different programs do it differently.
How are you doing the
Over here, there's a superscript.
Okay, I was just
Nope,
wondering.
no,
Not that
good,
I've
good.
written it yet.
By
but
all means. In fact,
how do I
actually,
do the
I messed that one up.
Okay.
It's weird when you want to edit it. You have to select that and only that, and then I can say it's 3. Oh, but I did. Okay, that's 2 to the 3rd. This one is 2 to the 4th, and this one is 2 to the 5th. Okay, now what is 2 to the 0?
2 to the 0 is 1 because everything.
Because,
2 to the 0.
okay, so he said
anything to 0.
anything to 0 power is 1. It makes things work. Okay, well, okay. Every number system has a ones place.
Yes.
Every single number system has a ones place. Okay, what is 2 to the 1? 2 to the first power?
2.
Yeah. I was.
I'm sorry,
thinking-
Connor. I did hear you. I didn't mean to ignore you.
Okay.
Okay, I'll play this game. I'll keep going. What is 2 squared? 2 to the 2 power.
Squared is 4.
4.
Okay. Yeah, sure. Why not? Control V.
That one is
Control
8,
V.
and then it's 16, and then it's. I almost said 32. No, that would have been 6. That one.
No, you're right. You're right.
Is it 32?
Yeah, they keep doubling. So,
Yeah. Oh, and then
because we're
6 is
multiplying by 2
Yeah,
each
6
time.
is
Each time you add a place,
64.
that's 8. 16 and 32.
Yeah.
Now that's actually wrong.
That's what I thought. That's what I was gonna say. Is 2 to the 6th?
No.
is 32.
No. That's not the wrong part.
Well, no, it is wrong.
You did something that actually turns out to be useful, but it's a trick. You just played a trick on yourself.
It's a trap.
What was that, Connor?
I said it's a trap.
Yeah, probably everything's a trap in here.
I was. Wait, so. I get it.
I don't. I'm gonna sit here for a few more minutes and then I have to go. So.
Yeah, I understand.
I don't.
And we can keep going with this stuff.
I
here.
would stay if it wasn't for the fact that I have a job interview in 15 minutes.
Oh,
so.
well.
Well, it's just a student life.
Oh.
It's not that far away. I just
Okay.
wanted to get there and get there early.
Yep,
you know?
I understand completely.
So.
Okay.
I was hoping I could.
Good luck.
After I'm done with that, I will try to come back and hope you're still here because I do need your.
I probably won't be here much longer. But
Oh,
I submit, you can think about it, these are the correct place values. You played a trick when you did this, and I'm not going to fall for it.
I was more confused.
These
I thought it was
values
phase 2.
Are expressed in decimal.
So.
These are the binary place values. In fact, the place values are the same in every single number system. Remember, what did we say this was? This represents the fact of how many 100s you have. Like we had 1 100s up here. What does this say? This says that's 2 in binary. So in binary, how many 2s do we have? In binary, this is 4. How many 4? So these are the actual place values in binary. What you did mentally was you did a conversion from binary to decimal.
Oh.
Which is a handy trick, but just don't get fooled that no, those are not the binary place values. Those are the base 10 place values of the binary places. Go, run, get out of here.
Oh, cool. Awesome. Have a good day.
You too.
Save. Oh yeah.
Okay, is Connor, are you still there?
I'm still here. Yep.
How you doing?
Doing all right. Apologies for showing up a little bit late. I'm also taking Matthew Haas's class too, and I've been struggling with the word problem. So I was just deep in on that. And then I look up and it's like, oh, it's 2:15. So that's why I was a little bit late today.
I understand. I don't know. I don't think I can help you much with that. I mean, I can help you with the problem, but not some course. Yeah. If you want help with the actual problem that you're solving, I'll try to help. But as far as the time issue and the lack of procrastination, the due dates and so forth, his classes have all that.
Yeah, it's not due. Like he moved everything forward for a week. I was still trying to tackle it, try to get ahead of the game.
Which good. I applaud you for that. Don't wait. I mean, he always makes everything due his he has one project a week and they're due on Wednesdays kind of thing. And I know it's hard for people. It's hard to get people in my classes to do something on Tuesday because they're busy trying to cram in their thing. But anyhow, yeah. So, like I said, if you want to bat some ideas back and forth, I won't give you an answer to a problem, but I'll help you work through it.
I'm slowly starting to think, like I'm just right now doing process of elimination. I'm doing things as we work out. I'm also like, I was also struggling a little bit with the concept of long division too, which I haven't done. I don't think I liked girls the last time I did long division. So,
Oh gosh, I hear you.
Oh.
I hear you. Yeah, Cam.
so that's why I was struggling with. I was just kind of lost in the sauce, which kind of felt good because if I can focus on something, then
Yeah.
I'm not getting distracted by something. So
Okay.
I was just lost in the sauce on that. I am slowly chipping through it.
Okay. Well, like
I'm,
it's
I am, I'm starting to piece through it. I'm not trying to, I'm not going to ask for answers because that's
yeah,
defeating
like
the
I
purpose
won't
of it.
I won't give you an answer. I would encourage no one else to give you an answer, but like I said, it's a problem. So that would be well suited to feel free to post it in problem solving Discord, and we can all, learn something from it.
Okay. All right. Well, maybe I'll do that if I can. I am slowly trudging through it, so I'm not sure if I want to like this, maybe this. I'm trying to get like my brain muscles back in shape,
Yeah.
if that makes sense.
It's actually, I would say, it's kind of an extension of what we were just doing. So, but we were starting at the basics. We were starting with counting and place values and the symbols and manipulating them. And that jumps right to division. But you just have to
Yeah.
think through. You have to think through all the little steps in the order you took them in when you learned long division. And because he's going to do the same thing, he's going to extend that long division from decimal to other bases, other number systems. So there's a lot of overlap. And it would be good.
Yeah.
So now I'm thinking about it, if problems like that, you could even post them in here in Essentials. It'd be good for us. So anyway, either of my Discords, feel free to post it in there. It would be good for everybody to see a little bit of it and think about it. Interesting problems.
Okay. There's probably some overlap. I'm pretty sure. I think there's got to be somebody that's taken one of the other two courses I'm taking with them. So,
well, and if they
Yeah.
haven't,
I'll try doing that.
they probably will. So this will be good for them to see what they're getting into.
That makes sense. I'll probably post that a little later tonight. But I'll probably have some corned beef that I cooked up last night.
Ooh, that sounds good. Okay.
Yep.
Well, enjoy your evening.
I will.
Okay.
Farewell.
Bye.